In this video lecture, we shall see the working of a nMOS transistor action. Okay, and it is one of the most commonly asked questions in the exam. Okay, so the working of this enhancement mode nMOS transistor can be explained in three regions. The first is the cutoff region. The second is the ohmic region. It is also called as linear region. The third is the saturation region. Okay, so in the cutoff region, as you can see, so since this is nMOS, we have a P substrate and there is N diffusion, fine, source, gate and drain. In cutoff region, your gate voltage is less than the threshold voltage, okay, because of which there is no channel being established and you can say the transistor to be in off condition. Okay, so when you operate a transistor in off condition, okay, so it will be either in the cutoff region wherein it will be in off condition, or it will be in the saturation region wherein it will be in the on condition. Okay, so this cutoff region is nothing but the off state of a transistor. Fine. The second region, okay, it is also called as the ohmic region. Okay, so several names are there: ohmic, resistive, they are one and the same, triode, non-saturated. This linear region, they are explained in two cases. Okay, the first one is when your gate voltage is greater than the threshold voltage. So obviously when your gate voltage is greater than the threshold voltage, a channel is established because of the inversion layer. Okay, remember we have explained this in the inversion mode. Okay, so inversion layer is formed because of which a channel is established, and now, so when the channel is established, so in this condition the drain to source voltage is 0. Okay, this is case 1. Okay, now because the drain to source voltage is 0, so there is no potential difference. Okay, hence no current flows between drain to source. Fine, channel is established but there is no flow of current, there is no conduction of the current. Okay, because the potential across source and drain is same. Case B is when the gate voltage is greater than the threshold voltage, but you are applying a positive voltage between drain and source which is less than gate voltage minus the threshold voltage. Okay, now what happens in this case? First thing is, because of the potential difference, because you have applied a positive voltage, okay, there is conduction of current. Now the current starts flowing from drain to source. Okay, and the channel resistance of the channel also varies across the length. Okay, because of which there will be a voltage drop across the channel. Okay, now what is this? Why is this depletion region increasing? It is obvious, right? Because you are applying a positive voltage. Okay, there will be positive charge particles here. Okay, and P substrate also has holes as majority carriers, because of which the depletion layer increases. That's what it is shown here. But in this condition, still the channel exists and the conduction of the current is brought by the majority carriers of N type, that is the electrons. Okay, that's why this region is called as the linear region. Okay, the third region, okay, which is the saturation region. Okay, so this is the region in which we say the transistor is used as a switch. One is the cutoff region, the other is the saturation region. In this region, your gate is greater than the threshold voltage, but the drain to source voltage has been increased to a level that it is greater than the difference between the gate voltage and the threshold voltage, because of which now the channel which was formed by the inversion layer, okay, it is now no longer inverted. Okay, and as you can see, that region wherein the channel has got diminished, it is called as the pinch off region. But because of the greater voltage here, okay, the conduction still happens because of the drift of electrons. Okay, remember, the conduction here in MOSFET, in the saturation MOSFET, is not because is no, is not due to the diffusion of electrons, but it is due to the drift of electrons. Okay, and in nMOS, since electrons are the majority carriers, the mobility of electrons is higher. That's why nMOS is preferred over PMOS. Okay, though the channel has been inverted at the drain region, still the conduction takes place, and the transistor is said to be in the on condition. Okay, the same has been depreciated in this diagram. Okay, unless VDS was less than VGS minus VT, you can see a linear curve. Okay, as the VDS increases, the channel resistance also increases. Okay, but when your VDS is greater than VGS minus VT, there is no effect of the gate voltage now. You go on increasing the gate voltage, the transistor is still said to be in the on condition, and VGS has no effect on the channel in the saturation region. Okay, this is a very important question, and also this is very important in understanding the working of a MOSFET transistor. Okay, now in VLSI, we basically use a MOSFET as a switch because ultimately it is the binary, either 0 or 1. In that case, MOSFET is either operated in the cutoff region wherein the transistor is completely off, or the saturation region wherein the transistor is in on condition. Okay, so please study this carefully and understand the concept. The same you can apply for PMOS enhancement transistor. Only thing is, everything will be opposite. Okay, so that's about the enhancement mode transistor action.